Today's lesson is an introduction on quadratics. Everything that we are going to do in today's lesson is review from last year. I am going to start right from the beginning, but again, it should all be review, and so after this lesson, I'm hoping that it slowly starts coming back to you. We're going to go through some properties of quadratics. We're going to take a look at some of the forms that you're going to be seeing this week. We're going to be calculating some first and second differences, and then you're going to have some time to work on your properties of quadratics assignment for this morning. This first slide is talking about the key features of a parabola. So we have some key features that are labeled here with these black circles. So I think the first one that we're going to talk about is the y-intercept. And this one probably is going to be the easiest for most of you because we've talked about y-intercepts in this course before. The y-intercept is this point that the parabola crosses our y-axes. The next key feature, I guess, that we're going to be talking about is called the vertex, and it's this point at the very, very bottom of a parabola, or if the parabola was facing the other way, it would be the point at the very top. The third key feature that we're going to be talking about are the roots. So this is where the parabola crosses the x-intercept. So these 2 points right here and here. And we are going to be learning how to find these roots. So we have already, factored, and that's how we're going to be eventually finding roots in this course. For today, though, you only need to know how to label these things. You don't need to know how to find any of these things. The last key feature that I want to talk to you about is this line that's in the middle right here, this dotted line. This is called the axis of symmetry. So if you think back to when you were in JK or kindergarten, if you painted on a piece of paper and you folded it in half and you opened it up, you would get the duplicate on the other side. And that's exactly what we're talking about here. So this axis of symmetry line just basically says that everything that's on one side of it is duplicated on the other. On the previous slide, I was talking about the vertex, and I mentioned that the vertex was the lowest point or the highest point on the parabola. So if our parabola opens up, like this first example right here, then we know that the vertex is this point right at the very, very bottom. We call this a minimum because this is the lowest that this parabola will ever get. Likewise, if we have a parabola that opens down, and you'll often hear me call this a sad parabola, and I'll call this one that opens up a happy parabola. Its vertex is right at the very, very top right here, and we call this a maximum because this is the highest that the parabola will ever get. What is going to be expected of you by the end of today is something just like this chart. I want to be able to give you a picture of a parabola and have you answer all of these key features. So we will do one parabola at a time. So we'll do this first column here. This is what we would call a happy parabola. And so this means that the direction of opening is up. Its vertex is this point right at the very, very bottom. When we're listing a vertex, we always need to list it as a true coordinate. So the x part and then the y part. If I'm looking at this, it goes over -1 on the x and a -2 on the y. So again, we were going to go over to -1 on the x and then down 2 on the y to get to that lowest point possible right there. Because it opens up, or just by looking at it, we can see that this has a minimum and the optimal value. So this means what is the lowest it could get, or what is the highest that it could get. So since this has a minimum, the lowest that it could get is -2. Now the interesting thing is that this optimal value is always just the y part of our vertex. The next interesting thing is the axis of symmetry. So when we write an axis of symmetry, remember, this is the dotted line that we can draw in here that would make it symmetrical on the left and the right. So this always has to say x equals, and it's always just the x part of the vertex. So x equals -1. We have two more key features. So when I look at this parabola, I could see that it crosses the x-axis 2 times. The first time is at -3, and the second time is at +1. And then last but not least, our last key feature is the y-intercept. So we need to say to ourselves, where does this parabola cross the y-axis? And I can see that that happens right here. And it's a little bit hard to see. We're going to have to take a guess. Approximately -1.5, -1.6. If it is an assignment, I would try and make it as nice as possible for you, I guess I'm trying to say, but I would take within a range here. So it's definitely bigger than -1, definitely smaller than -2. At this point in time, I want you to pause the video and attempt to do this next one by yourself. It does look a little bit different. We can only see a portion of this parabola, but if you picture what's happening, it would continue on. I hope that you've now paused it. This parabola is a sad parabola, and so it does open down. That means that the vertex is the very, very top of this parabola. So if we're thinking about this coordinate, again, we do the x first, so it goes 5 in the x, and then the y value, so a -1. Since it does open down, it does have a maximum value. And again, that maximum value is just the y part of the vertex. So the highest that this graph ever gets is -1. Likewise, for the axis of symmetry, it is this dotted line through the middle of our parabola, and it happens at x equals whatever the x part of the vertex was. So x equals 5. If you forget that little hint, you can just look at where you drew this line in, and it crossed right through the 5. The next thing that we're going to look at is the x-intercepts. So this parabola actually never crosses the x-axis, and it never will. So this one was kind of a trick question. There's no x-intercepts. And then finally the y-intercept. So we're looking at where this graph crosses the y-axis, and it's that point right there. So somewhere between -3 and -4. So again, we'll say -3.5. I want you to take a minute right now and use Desmos to graph a few parabolas. There's a couple right here, and then try and see if you can notice any patterns between some of these. I am also going to attach a worksheet that you can take a look at, and then try and work your way through that. So if you want to pause the video right now and go to that worksheet, you're more than welcome to, or you could do it at the end. The last thing that we're going to talk about in this lesson is identifying a type of function based on the table of values. So in grade 9, we did something called first differences, and we took a look at those again this year as well. So when we're calculating first differences, what we need to do is we need to look at the y values in our table of value. We're going to take the second one and subtract the one right above it. So in this case, we're going to do the 3 take away the 1. And when I do that, I get 2. I'm going to do the exact same thing. I'm going to do the 7 take away the 3 to get 4. The 13 take away the 7 to get 6. 21 take away 13 to get 8. And then 31 take away 21 to get 10. Since these are not the same, that means that it is not linear. If they were all the same, then this would be a line or a linear function. If they're not all the same, we're going to attempt to do something that we call second differences. This is where we take the first differences and calculate the differences of those. So we're going to do the exact same thing, but this time we're going to use the first differences. So 4 take away 2, that's 2. 6 take away 4, that's 2. 8 take away 6, that's 2. And then 10 take away 8, that's 2. Since these are all the same, that means that this is a parabola or is quadratic. I want you to take a minute right now and I want you to attempt to do the first differences and second differences for this function. And then after you pause the video and you try and do this, I'll have the answers put up for you. So hopefully you've paused the video and you attempted to do these first differences. So when I take a look at these, I'm going to do the second number. So this 15, take away the number right on top of it. 15 take away 18 is negative 3. 12 take away 15, negative 3. 9 take away 12, negative 3. 6 take away 9, negative 3. 3 take away 6, negative 3. Since these are all the same, that does mean that I have a linear function. There is no need to do the second differences if my first differences are the same. I have 2 more examples right here, so I want you to try and do this first one. So pause the video now and then I'll put the answers up. So when you calculate the first differences for this one, you're going to notice that they are not the same. 6 take away 3 is 3, 12 take away 6 is 6, 24 take away 12 is 12, 48 take away 24 is 24, and 96 take away 48 is 48. I did go on to do the second differences. So looking at these first differences, I have 6 take away 3 to get 3, 12 take away 6 to get 6, 24 take away 12 to get 12, 48 take away 24 to get 24. Since these are not the same, I do know that it is not linear and that it is not quadratic. If it is not linear, not quadratic, there is one third thing that we want to try. We want to try and do the ratio. Ratio is the exact same as first and second, except instead of subtracting, we're going to be dividing. So I'm going to be doing 6 divided by 3. That gives me 2. And then I'm going to be doing 12 divided by 6. That gives me 2. 24 divided by 12, 48 divided by 24, and 96 divided by 48. If the ratio is all the same, that means that we have an exponential relation. So this is something that looks like this, which is what we did last week. You're now ready to go to your assignment for this morning. So you're going to be doing the properties of quadratics assignment and handing that into the proper drop box. Like I mentioned earlier, there is a worksheet that you can go through before if you would like. And then if you have questions, please let me know how I can help.